Let's see the time series analysis in the data analysis. Here, our example dataset is weather. A time series is simply a series of data points ordered in time. In a time series, time is often the independent variable, and the goal is usually to make the forecast for the future. At this learning platform, we provide seasonal ARIMA as the major model to do the analysis. Now, so let's select analytic method and time series analysis, and then select seasonal ARIMA. For the options page, we can see there we have selected date column. So the date in this dataset is the column date, and select the target column is our average temperature. Before we set parameters for the option page, let's go to the advanced options. Let's decompose the dataset first to check the dataset. Now we can see there's a plot about the seasonal ARIMA. From this plot, we can see this dataset has strong seasonality. Seasonality refers to periodic fluctuations. If the dataset shows a strong seasonality before modeling with the seasonal ARIMA, we must apply transformations to our time series to remove seasonality to make the dataset stationary. The common way is differencing. Here we can have some options. We can remove the seasonality by first difference, second difference, and season first difference. And then we can check the stationarity by some test model. Stationarity is an important characteristic of time series. A time series is said to be stationary if its statistical properties do not change over time. In other words, it has constant mean and variance, and covariance is independent of time. But our dataset is about weather. It's cyclostationary, which is a process with a periodic mean and a periodic autocorrelation function. So we can treat it as stationary. But we also want a more statistical way to test the stationarity. Usually, we can select the original dataset, let's confirm, to test the stationarity. We can see the result. Augmented Dickey-Fuller test is our model, our function. The null hypothesis is that the data series is not stationary. And then by calculating, we can get the result. It shows that strong evidence against null hypothesis. So we reject null hypothesis. Thus, original data is stationary. So it's time to model our time series. Let's go back to the training model. Now we can see there are some parameters here, lowercase p, lowercase d, lowercase q, and capital P, D, Q, and M. So lowercase p, this means the trend autoregression order. To find p, we look at the partial autocorrelation plot. Let's go back to advanced options. You can see here there's an option check correlation. We can select the original dataset, select PASCF. This is a partial autocorrelation plot. Let's confirm and check the result. So we can see we identify the lag after which most lags are not significant. So this is the third one. 1, 2, 3, the third one. So P would be 3. Let's input 3 inside here. And then for the Q is the moving average model. We take the parameter Q to represent the biggest lag after which other lags are not significant on the autocorrelation plot. So we go back to the advanced options and check correlation, check the SCF. Then let's check. 1, 2, 3, 4. So 4 is Q. We'll put a 4 inside Q. Because for the D means the trend difference order. So in this data set, we didn't do any differencing to make the series stationary. So we put a 0 inside. And for the capital P, D, Q, those are for seasonal component. So they are same as the lowercase p and q. So let's put 3, 0, and q is 4. M means the length of the season. So for the weather is 12 months. And then let's confirm. Let's check the model. Sorry, here the advanced options here. Let's go back to choose to none, so we can check the model. Okay, now we get the result. And we check the residue. It's very close to 0. That means our model has very high accuracy. And then if we want to predict the model, we can go back here and put the future time period inside it. Suppose we want to predict the next 12 months. Target color is our average temperature. Let's confirm. Okay, we can get our result. So for this plot, we can see the green part, the green line, it represents the next 12 months temperature. We also have some demo code for the seasonal REMA. So note that only 2 variables, data column and the target column, are changed automatically based on user's options. But other parameters are just an example. Like in the order, there's 0, 1, 0. Those are P, D, Q. And the seasonal order, P, D, Q, and M.